This is a bit of an extra video. It's stuff that's important for building the robot if you're following along with the robot build project, but that didn't quite fit into the ROS2 control video. It wasn't directly related to that. But if you haven't watched that one yet, go and watch it first and then watch this one. It's just a bunch of config changes and software fixes that we need to do before we go ahead and try to run ROS2 control on our actual robot. And just so you know, for the demos that I'm doing in this video, I'll actually be driving it with a controller. I know I haven't covered how to do that in the main videos yet, but it just makes it a bit smoother for these demonstrations. Don't worry about that. You can do the same thing with Teleop keyboard. Before we get into fixing any bugs, the first thing I want to do is to upgrade my URDF to match the actual robot that I've built, rather than just the example one that I've made before. Now, obviously this is going to be pretty specific to my robot, so I'm just going to fast forward through this bit. You can do yours however you want to do according to your build. But if you do want to know exactly what mine was, you can check out the file at the end and see what I did. All right, I'll be honest, things don't always work properly around here. And after I made those last changes and tried to run things again, I just started having a lot of really strange issues. Gazebo was behaving very inconsistently, RViz wasn't receiving transforms, and I still haven't figured out what was going on. It's a couple of days later now, so hopefully with a fresh day and some editing magic, we might get through the rest of this tutorial. But yeah, I still haven't figured out exactly what was going on. If you've got any ideas of what it might be, please let me know. But as you can see, we've now got our new URDF in, so hopefully it'll look a little bit more like my actual robot. Hopefully you can see that there. And of course we can still drive it around just like we could before, and we should see that in RViz, so I can drive it. But something you might notice, this is bug number one that we're going to tackle, is that it seems very choppy. You can see the robot movement is just, yeah, at a very low frame rate. Now, if that choppiness was just a visual thing, it wouldn't be such a big deal, but that's actually representative of the clock rate between Gazebo and ROS. You see, when we're running a Gazebo simulation, Gazebo gets to control time and it gets to pulse the clock at a particular speed, and it's only pulsing it at 10 Hertz, which means ROS is only interacting with the simulation at 10 Hertz. And that's not fast enough. That's actually going to cause potentially some wheel drift and that sort of thing. So we're going to tackle that. Now, fixing that is not too difficult, but it's a little bit annoying. Newer versions of Gazebo and ROS are going to make this slightly easier, but not too much easier. So the first thing we're going to do is create another parameters file here. So we're going to call this one gazebo params.yaml. Inside that one, the name of our node is going to be gazebo, and then we of course have ROS __ parameters, and then the parameter we want is called publish rate. And we're going to set that nice and high. We're going to set that to 400 Hertz. Make sure you've got a decimal point there, otherwise it'll get annoyed. It'll think it's an integer rather than a double. So 400 should be plenty fast enough for ROS to be able to pick everything up. You could probably go slower without too much trouble. And now we need to tell Gazebo to read this params file when we launch it. So we'll go down to our launch sim, and here is where we are including the Gazebo launch file. And this is including the ROS Gazebo launch file in ours, and the ROS Gazebo launch file exposes a launch argument that lets us send extra arguments to Gazebo. So just like we did here with our robot state publisher launch, we're just going to copy that syntax. I already got a comma there, so we don't need that first bit. But this time the name of the launch argument is extra Gazebo args. And then this is going to be a string, so it's -- ROS args -- params file, and then space, plus, and then now we're going to need to provide the path to that parameters file. So I'm going to make a string in a second called gazebo params file. And to get that, I'm going to use this same Python function here, the os path join. So go gazebo params file. Let's just get rid of some of those extra new lines that we don't need. And so it's going to be get package share directory package name. That's what we want. So it's articubot1 /config /gazebo params.yaml. So we'll go config gazebo params.yaml. And so that will construct that whole path to that file. It'll put it into that string, which is then getting passed into here. So that should be all good. We've got to make sure we rebuild because we added a new file, that Gazebo params file. So now we'll kill Gazebo and rerun it. And hopefully we'll now see that as we drive it around, it's very subtle, but the robot is moving much more smoothly. Now, the next problem we're going to run into is another issue with wheel drift. So I'm just going to restart that Gazebo again. All right, now we should see that to start off with, our robot is facing forward in Gazebo, and it's also facing directly forward in RViz, as you'd expect, lined up along that axis. But now watch what happens if I go to drive a single revolution and end up pointing pretty much exactly back along that axis. We should be back where we started in RViz. But you see I'm actually pointed a fair way off. Those wheels are drifting. And I think that's because, you see how we've got these cylinders here? They're going to have, I guess, a bit of frictional thickness along the length of that cylinder that's causing those wheels to drift in the simulation. Now you could argue that maybe that is actually more realistic for the real robot, and we want to leave that in there like that. But I want to make the simulation, I guess, a bit more perfect. And so there's a few ways we can do that. We can reduce the thickness of that cylinder so that it reduces the contact point. But we're going to do that by a way that reduces it to infinitely small by changing it from a cylinder into a sphere. So we're going to go to our robotcore.xacro, down here to our collision geometry. So we're going to leave the visual geometry the same. It's still going to be a cylinder, but we're going to change our collision geometry for both wheels to be a sphere. And then we'll get rid of the length. So you can see now our right wheel is a sphere, our left wheel is a sphere. I'll relaunch Gazebo. Then if I enable the collision view, you should be able to see that these are spheres now, even though the visual is a cylinder. I'll just turn that off. And we're facing forward in RViz. So we'll do another revolution. Oh, I accidentally drove a bit off center there. But we should see that we're now facing very close to straight ahead. So that's corrected that drift. Now it's time to see a third issue. Now this one, I'm warning you, I don't have a fix for. It's not a huge issue, but it can be a deal breaker for some situations. So what you'll notice in RViz, if you have a look at the locations of these obstacles, is when I start moving, they kind of jump back and forth. So if I keep moving left and right, they're jumping around. Now, you might think that this is to do with acceleration limits or, again, some kind of wheel drift, a friction slipping issue, but I've spent ages digging around and I absolutely cannot find anywhere that is being caused by this in the simulation. I'll include some more information about this in the description and in the blog post, but as it is, I've got no fix for this, and it actually makes doing slam and that sort of thing really difficult, because as the robot turns and tries to generate a map, you end up with obstacles being kind of smeared across the map. If you drive very slowly, it reduces the severity of it, so sometimes that's a solution depending on what you're doing, but for some cases, we might just have to revert back to the old method of using the built-in Gazebo differential drive plugin rather than the ROS2 control one. You can still use ROS2 control in your real robot. I think it's something to do with how it interacts with the simulation. And so that means we need a way, if you remember, we actually commented out Gazebo control. It'd be nice to have a way to be able to toggle between the Gazebo one and the ROS2 control one. And so we're now going to look at how to do that. So the first thing we're going to do is to add an xacro argument here. So we do that by going xacro arg, and we give it a name. So I'm going to call mine use ROS2 control, and a default value, which we'll make true, because most of the time we are going to want to use it. It's just sometimes that we'll want to swap to the other method if we're having trouble. Now, the way that we do conditionals in xacro is a bit weird, but we go xacro if, so that's not too unusual, and then the thing we want to check. So in this case, we're checking if using ROS2 control. Oop, missed my quote there. And then, of course, we want to put, oop, I've done these the wrong way around, haven't I? let's get that out of there. So if we're using ROS2 control, then include the ROS2 control xacro. Now, instead of having like a else that you might be used to in languages like C++ or Python or whatever, instead it's xacro unless. And so it just considers the positive condition and then considers the negative condition. So we'll get that, put it down there and make that unless. And then we'll just fix up our indenting. So it looks a bit strange, but this is saying if we're using ROS2 control, include ROS2 control. Unless we're using ROS2 control, include Gazebo control. So hopefully that makes sense. The next thing we need to do is actually pass that value down from up at the launch file level into the xacro when it's called. Now this bit gets a little bit funny. So if we go to our robot state publisher.launch.py, this is where we were calling it. So you can see here we get the xacro file and then robot description config. We use the xacro Python module to process it. And this does actually provide a way for us to pass arguments down. So we can do that using the mappings argument. So we go mappings equals use ROS2 control and so on. However, what I want to actually do is I want to include this robot state publisher launch in the launch sim and be able to pass it down as an argument to the robot state publisher launch. And unfortunately, if we take this approach of using the Python module to process the xacro file, just the way that launch files work, we're actually not going to be able to pass that the whole way down. It's going to get stuck in the way that it processes it. So there's a bit of a workaround. It's a bit annoying, but instead of using the Python module, we're going to actually just call the xacro executable directly from the launch file. So the first thing I'm going to do is to just take this 2xml from here and put it to there. All that's doing is the output of this before was kind of some xacro object that was ready to be converted to an XML file. Instead, I'm now converting it here. So this is going to turn it into a string. So this variable will now contain a string. And that way, the new one, which will also put out a string, if we ever want to swap back to the old one, we can just swap that comment. So we now go robot description config. And what's this going to equal? So what this needs to do is it needs to make a call out to a system program, in this case, xacro. And that's what's called a substitution. Oop, I've spelled description wrong there. So in the same way that we've got our substitutions up here, like our launch configuration, we're going to use the command substitution. So this is going to say, where I was going to have this variable, substitute it with the output of a command. And so this is going to be command. And then in here, we just put the string of the command that we want to execute as an array of strings. So it's going to be xacro, and then the path to the file. So xacro file. And then we just specify the arguments directly at the command line. So use ROS2 control, and then whatever the value of this is going to be. And like I said, we're actually going to make this a launch argument like we did here. So I'm going to call this one use ROS2 control and use ROS2 control. And then whatever the value of this is going to get substituted into there. So it's kind of this chained substitution. So when it goes to launch the robot state publisher node later, it's going to say, oh, I need the robot description config, which rather than being a string, it could be a string, but now it's going to find that it's a command that it needs to execute. And within that command, it's going to find the use ROS2 control, which is going to get from the launch configuration. Very confusing, but just bear with me. And we should also just declare our launch argument. It's just a good thing to do. So we'll call this use ROS2 control. We'll set the default to true this time and use ROS2 control if true. All right, so that means we can now pass that in as an argument to robot state publisher. So now here where we've got our robot state publisher include, we've got use sim time is true. We can also have use ROS2 control. And I'm actually going to set this to false. So we can just check that it will go back to the old method if we do that. So that should be good. Let's, I don't think we need to rebuild, but let's just do it anyway. And now when I relaunch Gazebo, oh, what have we got here? Command substitution failed. Now I found what the problem is. I was just doing this off memory and I forgot that when you are passing arguments, they work a bit different to regular variables. So instead they've got to be in parentheses rather than braces, and we have to have the word arg in front of them. So make sure you just quickly go and change that. And now let's try running that again. So you can see it's running, and you'll notice that this time when we look at our printout, you'll notice the controller spawners are failing because there's no controller manager and no controllers, because it's loading the diff drive plugin instead of the Gazebo ROS2 control plugin, which is exactly what we wanted. So if we just kill that and now go back to our launch and change that to true and run it again, let's see what happens. And look, it's worked great. It's loaded up our controllers just like we wanted. A couple of last things I wanted to talk through. So hopefully we'll see here that if we enable our camera, we can be driving around, and apart from that bug, things are looking pretty good. We can see our camera data and our LiDAR data there. We can move around, look at what we're doing. So I want to actually save this RViz configuration to be able to use later. So I'm going to say save config as. Now, instead of saving it to the default, I'm just going to put it in that same config directory here. So I'm going to call mine, I've already got one called drivebot there, but I'll call it main.rviz. You can call it whatever you feel like. And that way, next time we start up RViz, we can just type rviz2-d and then the path to it. So in this case, source tikibot1 config main.rviz, and then we'll be able to start right back up where we were. There you have it. That's just a bunch of quick little things to fix up before we go and get ROS2 control running on the actual robot. As always, if you've got any questions, let me know in the comments or over on the discussion thread. That'll be the discussion thread for the original video. There won't be a separate one for this one. And thanks again to everyone supporting the channel on Patreon and just in general. I look forward to seeing you in the next video.